So welcome to the Red Hat BU Colloquium series. Great to see so many people here and folks online. Our topic today is open source AI at Red Hat, and we're very lucky to have Sherard Griffin visiting us. He's the leader of the engineering group, among other things, that concentrates on our OpenShift products. And this year is a really important year for the Collaboratory at BU to cooperate with the OpenShift research, both being done here and what Red Hat folks are interested in pursuing. And also we're scaling up the Mass Open Cloud a lot, so we expect to have a lot of users who are going to take advantage of AI services. And so we're looking to get your inputs on what you'd like and what research topics you're interested in. Sherard is a very easygoing guy, despite having the weight of the world on his shoulders.
Super laid back.
So feel free to interrupt and ask questions or start a discussion at any point. Just so that you know, this is being recorded, so we will share it with other people afterwards online. And if you have things you want to ask about that you don't want recorded, then just come up after the talk. Thank you.
Awesome. Thanks everyone for having me. I don't know if you're here for the free food or for the topic, but I'm going to assume it's a topic. So this is exciting for me to talk to all of you. There's a lot of great things happening at open source. Before I get into the slides, just a little bit of background. Red Hat's been in the AI space. We're relatively new to this. We've been in it for about 6 years. I came to Red Hat to start one of the initiatives in that space, which is now a product. And I think it's important for everyone, if you're not familiar with what we do, we're really focusing on the hybrid cloud story. When we start to look at what customers are concerned with, they're worried about their workloads running in different environments, whether that's bare metal, virtual machines, cloud, on-premise, all kinds of complexities. And so a lot of what we try to do is destigmatize AI for those customers that have those challenges. And what you'll hear me talk about today is a lot of the enterprise challenges that we see, but I think it's also a great opportunity for research. And so by all means, just like what Heidi said, if you want to stop me, if we go totally off the rails, that's fine. If you guys have a topic or some questions that you have that you want to go through, that's fine, because I did also mention to Heidi, there's so much information that I could have put in the slides. It's already way too bloated. So I'm happy to skip stuff if we need to. It's a fantastic space, a lot of research opportunities, and I'm going to kind of dive right in. I don't need to tell all of you this. AI is permeated just about every aspect of our lives. In fact, I was just over at one of my friends. He's a music producer. I was at his house last night. And gosh, every time I turn around, we're talking about AI. So they're even concerned about AI writing music and will that put him out of a job. We were having jokes because he does a lot of stuff for the Real Housewives. I was like, that is clearly a space we should do AI. But even if we look at what's happening in technology as a whole, you have GitHub Copilot, you have Bing Chat, you have what we launched with Ansible Lightspeed. Ansible Lightspeed allows you to define your infrastructure by just typing plain text. I need an EC2 server launched on AWS with this type of security. And you just type it in plain text and it writes the code that allows you to do that. But what's changed recently is that the consumer trust is starting to grow with AI. It's not just enough that we have AI in our systems, but my kids, they've grown up with Alexa. And in the morning, they trust Alexa's gonna wake them up. They also trust that if they ask it a question on their homework, that they're gonna get the right answer. I was recently in Singapore, and it blew my mind that there was a robot delivering my food to me in a restaurant. Maybe 10 years ago, I might not have trusted where that food came from, but today, that's a totally different ballgame. And even if you look at autonomous vehicles, we now have cars that use AI to detect people. And in fact, my car stops if a person walks too closely in front of my car.
Well, you're saying this when Cruise just shut down operation because of accident.
Well,
because of dragging a person on the floor for 7 feet. Yeah.
That gets to a later slide. But yes, so there's a level of trust growing. I said growing, it hasn't grown, but good call out. The other side of this is generative AI and foundation models as a whole. It's growing as well. This recent poll from CDO shows that there's a growing adoption of generative AI in businesses. In fact, even in John Graham here, he's senior director. He's responsible for intelligent applications, platforms, and services at Red Hat. Even our groups are starting to look at ways in which we can use AI to better process what we're doing at Red Hat. And so, but the challenges that enterprises are facing, which is a little bit different than what you see in the research space, is how do I take what I want to do with AI and actually operationalize it? That is a huge, huge barrier for adoption in industries right now. And I'm not talking about the Microsofts and the Googles who have billions of dollars they're literally throwing into the space. If you look at the average companies, there's a lot that has to be done in order to go from a model that's been created to an AI-infused application. That's everything from gathering and preparing the data to developing the data, integrating those models into the developer experience, and then as you deploy that infrastructure, being able to monitor and manage that at scale. And throughout that life cycle, you're talking about a number of different personas that have to be interacted with. The business leader, data engineer, the data scientist, the ML ops engineer, application developer, IT ops. What we didn't show here is ProdSec, InfoSec. All of those teams need to be on the same page in order to operationalize these models. And one of the biggest things that struck us, and it's actually one of our big value propositions as Red Hat, is it takes on average a customer 7 to 12 months, 50% of them 7 to 12 months to operationalize their model, and 26% of them a year or more. Now, we know that AI is moving at lightning speeds. If it takes you 7 months or more to get a single model from research into production, the entire ecosystem could have changed in that time period. If you look 12 months back, we were barely scratching the surface with ChatGPT. Now businesses are relying on that for a lot of their processes. So if you were to start on an AI model that had LLM capabilities back then, you may have been completely obscured by the innovations that's happened in over the past 12 months. And so why is it so complicated? The actual building of the model, this little clear box in the middle, that represents just the small piece of this. This is the research work that happens and people iterating over things. But when you start to do this on enterprise levels and at scale, there's a lot of complexities that happen. There's the configuration of the infrastructure to be able to run these things, the data collection, the feature extraction, data verification, the actual management of the infrastructure to be able to scale up and scale out, the monitoring tools that you have to have. Like all of these things are typically not thought of until you start to actually push something into production. And this is actually real world scenarios because we're talking to customers today and we're trying to tell them, you are going to face these challenges, you just don't know it yet. And they keep saying, but we're totally fine running these models on our laptops. Well, once you try to develop that into a production system, that's where you're gonna run into issues. And what we try to do is paint a picture of, it's not too dissimilar from when DevOps started emerging in application development. And if you're not familiar with DevOps, it's the manner in which software is not just built, but also deployed and managed at scale. We haven't quite gotten there with AI, but we are. And this is the things that we're trying to teach customers. Yes?
Actually, that was the question I was going to ask you. So why is it so hard for them to not see it? Like it's always been with development of any production level deployment.
Yeah, what we see is a lot of them are not, they're just not at that point yet. I think you all may be, you may be so familiar with successful machine learning initiatives, but when it comes to corporate America and when it comes to enterprises, they're at the very early stages. They're still playing around with technology and still trying to understand it. And so for them, when they have a data scientist or an ML ops engineer come to them and say, hey, I have this cool model, they do a demo and the demo's running on their laptop. And I know this because we did this with Ansible Lightspeed. It's like, oh, that's great. All right, let me just deploy this in a Flask app and we'll be good to go. And our team had to tell even our own company, no, you cannot launch an enterprise solution where anyone can access this endpoint using a single Flask app running in a single container. It needs to scale out. And so I think it's just a part of an education where you're going to start to run into these issues, and we're getting customers better understanding. But part of what we're trying to do is bridge that gap with MLOps and DevOps and show that this is one ecosystem where all of these things have to work together. If you look at, actually, I'm going to skip this slide because I don't think it's relevant. There are three core pillars in terms of where Red Hat's focusing its efforts when it comes to AI. The first one is being able to support the AI workloads themselves. Customers, more of the larger customers, the NASAs, the financial institutes, they have massive infrastructure and they want to create their own foundation models. They want to create their own models and get them out there. I think Bloomberg just released their own foundation model. NASA just released a geospatial model that was built on top of OpenShift. And so we need to be able to support those massive workloads. The other thing we need to do is make sure that we are allowing customers to deploy those models in the hybrid cloud. A lot of the dynamics that you're seeing is customers want to train their data in on-prem environments because it's disconnected from the internet, it's most secure, but then they want to deploy those models into the cloud because that's where they get the elasticity. So we need to support that. And then the last pillar there, the one on the right, focuses on us as Red Hat building our products that are AI infused. And I mentioned Ansible Lightspeed that writes the code for you. We're looking at other parts of our portfolio where we're going to continue to infuse applications. So our team is really focused on the full picture there, those three pillars, and ensuring that we can tell a cohesive story there. And as a result, I don't want this to be a sales pitch, but if you did have money, OpenShift AI is a great product to buy that helps you with that. I'll just say that. OpenShift AI is our leading product in the AI space that allows for enterprises to deploy their build and deploy their models into the hybrid cloud. It is fully open source. Everything we do at Red Hat, it's not just a requirement, it's also a culture. We try to look at all of the active open source communities and look at ways in which we can pull those together into an ecosystem that helps customers with those challenges. So we're active in the Ray community, Kserve, Kubeflow, TensorFlow. We launched a community ourselves called Trusty AI, which is about AI explainability, bias detection, all of those interesting things. And then we have an open source community called Open Data Hub that pulls all of that together. And so if anyone's looking to get active in that, we could use free development, so please do. But how many of you knew that OpenShift AI was available for Boston University and that you guys have been using it? You guys were our first customers. And raise your hand if you knew that. Good. So a good amount of people knew it. The rest of you have been living under a rock. But anyway, OpenShift AI, it's available we launched it with you guys. You were our first customers. We launched it as a cloud service, and it really allowed you to scale out your research work with your classes and give you an environment where you can develop, get access to GPUs, get access to various libraries like PyTorch, TensorFlow in a consistent way. So I'm very happy to have that partnership with you all. It's been fantastic. I think we gave you deep discounts, but that's okay. It's still been awesome. I'm not yet graded on how much revenue I bring in. It's all about how many customers. Now, when you look at the stack, and I'm going to go through this a little bit quickly, but I just want to highlight, some of the parts of the platforms that we do focus on. I mentioned this is breaking down a little bit of the open source components that our technologies are built on top of in the communities that are part of that. We kind of look at this as two different problems to solve for our customers. One is the left side, which focuses on the training and validation. I want to create my own models. What does it take for me to do that? Again, I mentioned the story that a lot of customers start on their laptops, on their notebook environments, just running on the laptop, and they want to just play around with some technologies. In fact, I saw a demo yesterday. Someone demoed something at Red Hat in Brno, and they were just on their laptop, and they wanted to highlight the capabilities of the platform. Immediately, I cringed and said, "Man, why isn't that on OpenShift AI?" But on the training and validation side of it, when you start to look at if you want to do something like create your own foundation model or create your own generative AI, or you just simply want to create a model, a lot of times that takes quite a bit, especially if you're doing something like LLM, if you're doing like deep neural networks. It's going to take a lot of hardware, and a lot of times it takes GPUs. So typically, what you want is to be able to maximize the use of that infrastructure. And this is where we're doing some great partnerships with the MOC, with NERC, to be able to provide those capabilities. Imagine everyone in this room, you all wanted to submit a job, and there's only 8 GPUs available. Boy, it's gonna be a dogfight. Everyone's gonna go do whatever they can to get access to it at first come, first serve. Well, we're working on technologies like MCAD and InstaScale that eases that burden for people. MCAD is a queuing system where we're starting to look at ways in which we can optimize those workflows. That goes for quota management. Maybe a subset of you only get access to 2 GPUs versus all 8. Maybe there's a priority queuing where a certain group has higher priorities than another. And then it's also about how those workloads are deployed into the environment, into Kubernetes. How is it maximizing the utilization of that infrastructure? MCAD's been awesome. We've been doing a lot of great work there, and also working with the Kubernetes community to provide optimizations there. InstaScale is another technology where it allows you to, if you're running in the cloud, the cool thing about that is, let's say you have a RAID job to do some distributed training using PyTorch, and you needed to take up, I don't know, 100 GPUs, but you only had currently 8 GPUs in your system. Well, you submit the job, and it knows that you need to scale up your infrastructure in order to meet that demand. And so it's going to go reach out to AWS, say, hey, AWS, I need 92 more GPUs. Can you spin that up for me? And it's going to handle all that for you. And when the job is done, it's going to take that back down. So the idea here is optimization on your cost, right? You can reduce your cost by better, more intelligently using your infrastructure. On the other side of this, the right side, is the tuning and inferencing. On the tuning and inferencing side, we have a couple of technologies that we focus on. I don't know if you all are familiar with Kserve. Have you guys heard of Kserve before? So Kserve is an open source. It actually came out of Kubeflow. Are you guys familiar with Kubeflow? Oh man, I skipped out on a huge part of this. Kubeflow is a package of open source tools that allow you to do the end-to-end AI workflow, going from training to production. That's at the core of what OpenShift AI is based off of. Kserve is a graduated project out of that focuses on how do you provide the right infrastructure to do inferencing on the models that you're serving. So if you can picture a scenario where I have this model, I've created it, and now I need to hand it off to someone to deploy it into an environment. So the question was asked before, I think, gosh, remind me of your name? What's that? Jonathan. Jonathan. So Jonathan asked the question about the why is it different than DevOps? And when you look at the processes that have to happen, it's pretty much the exact same. I always say a data scientist will never get access to a production environment just the same way a developer would never have access to a production environment. And so you have to have the right checks and balances and being able to test things out in order to qualify that that model is ready for production. Kserve does a number of things. The first thing that it does is pretty awesome is it gives you APIs that wrap around that model. They're either REST endpoints or gRPC endpoints. And that makes it like instantly like a microservice where anybody can send data in, you get value out. And that's great for a developer who knows nothing about the intricacies of that model. You're handing off that container with that API, with those APIs to that developer, saying just go send the code to this, and you're gonna get something out, and you can infuse your application with that. The other awesome thing that it does is it allows us to do things like scale to zero. So if there's no traffic coming in, then just scale the infrastructure down so nothing is utilized. That's a tremendous save on customers. And then when traffic does come, it'll automatically scale that model up, and it'll actually scale up many pods with that model. As you're growing more traffic, it'll automatically scale up the pods to be able to handle the traffic. Yes.
Do you have an idea on how much is required to scale up and down? Like, how much inconvenient can that be? in order to.
If you were to do it manually,
No,
Or-
suppose it happens pretty often.
Yeah.
What overhead we have?
yeah, so it depends on the size of the container, which is correlated to the size of the model. And this is something that we're looking into because we also have multiple technologies here. For example, within Kserve, we have a technology called Model Mesh. And Model Mesh is designed for a bunch of small models. So if you think of financial sector, they may have a small model for, do I get a mortgage today? They may have another small model for fraud detection, and they have maybe 100 or 1,000 of these small models. And in that case, when they're very small models, they can spin up really quickly. And in fact, Model Mesh is great because it's going to jam a bunch of those models in a single container. So you may still have, maybe one model is not getting traffic, but the other one is. You still save on, the infrastructure scaling up and down. Now, the challenge here is when you have LLMs, and this is where, part of the thing, one of the things to think about here is how do we look at ways in which we can optimize the memory footprint of LLMs, because they're getting to be pretty ridiculous. And so, some of the things that's being done is the LLMs are being more specific, right? You're not having these general all-purpose Llama 2 LLMs, but you're starting to say, like Bloomberg, for example, is just for finance, and that's all it's specified for. And so when you do that, you can reduce the memory, and then the time it takes to spin up that pod is far less than if you had, 1 gigabyte or 1.5 gigabyte in-memory model. So it really just depends on what that is. The other thing that you can do with Kserve is, canary deployments, where maybe you have a new model and you just want to roll it out to a small group of people and test and see if it works. That's kind of a way to where it's not quite hot, cold, or blue, green, but it allows you to have a deployment of that model and test out, is it going to scale up as traffic comes in? Is it going to take too long? Because one of the things is if you're using ChatGPT and it takes 3 minutes to respond because you're waiting for a pod to spin up, that's a deal breaker. No one's going to wait around for that. So canary rollouts, Kserve allows you to kind of test those things out. And we actually had this problem when we did Ansible Lightspeed. The very first versions of the model, we were trying to cut on costs and tried to do it with CPUs, and I think it was taking about 40 or 50 seconds to respond. And the data scientist said, oh yeah, the model's ready to go. And we said, oh, hell no. That's way too long if I'm waiting 40, 50 seconds. And so that's when it was like, okay, we have to do a trial here. We're gonna do a new model that's gonna leverage the GPUs. It's gonna cost us a heck of a lot more, but it got the response times down to 1 or 2 seconds, which was dramatically different. And so you constantly, when you're doing these production rollouts, you're constantly trying to make those trade-offs, speed versus cost. And I can pay more for having the infrastructure spin up faster, or I can reduce my costs if I don't have a lot of traffic coming in. Yes, Jonathan.
That just can't, it makes me have to think about the cost of models and expectations of the usage of these models. Because as far as I certainly have no real deep insight, but it sounds like right now, there's a very strange inversion, right? I mean, there's a lot of hype,
Yes.
there's a lot of expectation, and everybody's saying everything's for free. And that can't go with the amount of cost that it means to run a GPU and just simply power it, let alone do something with it. So where do you see that world going? When do we actually start seeing real costs reflecting the because until that happens, the optimization criteria and the push for us to actually optimize these things are gonna be disconnected.
You jumped ahead, but let me go ahead and do it.
I never
go
do
ahead and do it, Jonathan. Here we go. So the high cost of inferencing, you're 100% right. And let me say, how can I put this? I don't want to disrupt the sales of OpenShift AI. So I don't raise the red flag too much until after they purchased it. And then I say, well, you might have a problem. No, I'm just kidding. It is something that customers aren't fully understanding. When you look at inferencing as a whole, especially with generative AI, things that depend on neural networks and things that depend on the actual the amount of hardware it takes to run these at scale. I think when ChatGPT first came out, I saw an article that was costing them $600,000 a day to run ChatGPT. And so you immediately start to think, because a lot of our customers, they are not going to send their data to ChatGPT. There's a data privacy issue there, and I have an InfoSec slide as well that if I get to it, I'll talk about it. But they can't send their data to ChatGPT. So they're saying, hey, sell me OpenShift AI, and I'll take a Hugging Face model, or I'll take Llama 2, and I'll deploy it in my own infrastructure, and I'm good to go. And that's why I said before, you have people demoing this on their laptops, not understanding the complexity of getting it into production. So by the time the conversation comes, hey, we're going to get this into production. This happened with IBM Watson Code Assistant. We started crunching the numbers and said, oh, crap, this is going to cost more money than the revenue it's going to generate for the data coming in. And so that's where we have to start to look at ways in which we can optimize. And I'm going to get it. So many slides. I apologize. There's so much stuff I want to talk about. An hour is not enough. But if you look at quantization, right, is that an opportunity? If you look at sparsity, is that an opportunity? And one of the things that I'm starting to talk to more of our colleagues about, especially on RHEL. I don't know if you guys are familiar with Red Hat Enterprise Linux, but can we do optimizations all the way down to the kernel for the accelerators? Can we optimize PyTorch running on this so that it can run faster, and maybe you can get GPU-like performance just on CPUs? So, man, if there's anyone interested in that research work, please help us. Like that is a space that I'm very, very interested in. Like, how can we almost, for the majority of customers getting into the space, eliminate the need of a very costly V100 or A100 that they don't even know if they're going to get the value out of it yet? Does that kind of answer?
Yeah. Just as an anecdote, if you ask ChatGPT about this, it'll tell you that actually the transportation industry is worse. That's all it'll tell you.
Yeah, and so the point about this slide was, a lot of people focus on the expense of training a model. That's a one-time hit. Hey, well, not really a one-time. You're going to do hyperparameter tuning. You're going to iterate over it. You're going to continue to redo your model, get it more performant. But the inferencing side is where it can really trip you up, and we've seen that firsthand. We know customers are starting to see that firsthand as well, and they're looking for options. One of the other things, Jonathan, that I'm very interested in, so John runs a team called Cruise Auto Tune, and they've been working with the team Red Hat Insights to be able to help optimize workloads running on OpenShift. And so we've been talking, like, is there a way that we can do some cost optimizations or cost recommendations? Hey, we see that you're running it on this hardware with these runtimes. Can we recommend you do this if you want to run it cheaper, and actually do some analysis to provide those recommendations using AI? So that's one where everyone looked at me like, man, that's a great idea, but who the hell is going to do that work? Maybe you guys.
But this actually helps a lot, though, right? Because, like, for instance, we spent some time, we worked on a neural net accelerator in order to do high-speed inference at a reduced cost.
Yes.
But of course, nobody, we did this 5 years ago, nobody gives a rat's ass, right? Because, however, when folks like you start to point out, no, this is a real thing, instead of the hype that we constantly hear, which tends to force where the money goes in research and where we end up looking.
Yeah.
Just simply having the transparency that these are real problems.
Yes.
And it's not just us doing back of the envelope calculations. Telling you it's going to be a real problem helps us a lot. And then, of course, if we can get any data about the kind of the costs on current hardware, and where the both energy and carbon footprint costs go, that would be great.
Yeah, absolutely. That's another one of the carbon footprint. John, you want to say?
I was just going to add a little bit of perspective here, as well as, if you think back on the history of AI, there's been a few AI winters, right? And one thing that does worry me about this type of a thing is that, the types of customers that we're generally trying to sell to are roughly the mass customers. They're not the big companies that have billions of dollars to invest that can just do this. We're trying to make them, and if the cost equation doesn't work out for them, if they find out that it just costs way too much to actually run this stuff, then they will turn away from it because it doesn't make business sense. And for all of us who like AI, ML, and see potential in it and want to build a career in it, we don't want to have a situation where, amongst other things that could go wrong around like, concerns about robots taking over the world, other scary scenarios, you don't want to have a situation where businesses can't realize business value on this, because then they will stop investing in it. And then there'll be, fewer areas to do research and things like this. So I think this is really an important thing to tackle, and the costs quickly get out of line. It's just like in the old days with cloud, when people first started putting stuff on cloud. Oh, look, it's free, it's easy. I go sign up AWS, I do this, start running their business, and they're like, wait a minute, now I get this bill, and they're like, what's this now, right?
You mean like Google Docs?
Yeah, like Google Docs, exactly. So I think this is a really important concern for all of us, even if you're just looking at this like, how does AI continue to grow and become pervasive? We have to solve these cost equations and make it, affordable for companies to do, right?
So I have a famous quote by me. In order to democratize access to AI for enterprise, models must be cheaper to run, and the lineage of those models must be transparent and fully understandable. If there's anything that we all walk away from today, it's just thinking about what is it like? We have to have things running cheaper and faster, and we have to understand what's going on with AI. That's really the crux of a lot of the challenges for adoption of AI in businesses. And so when we talked about the optimizations, if you look at this stack diagram, I apologize for folks in the back that may not be able to see this, but it starts with the hardware, CPU, GPUs, the kernel drivers, RHEL drivers, software accelerators, model serving runtimes. That's your PyTorches, your Tritons. IBM has one called K-Kit, which stands for Conversational AI Kit, optimizations of the actual models running in different runtimes. And then the model servers themselves, K-Serve, Ray-Serve, model mesh. There's a lot of different layers. I think what I hope we can do on the Red Hat side is start to look at these lower level optimizations. How do we do better on the drivers, the kernel, RHEL itself? How do we partner up with Habana, Intel? We already have partnerships with them, but we need to make sure that we tell a story of these technologies are optimized to run AI workloads. So that's a real big area that I think Red Hat needs to shift its focus in. And then, this is kind of more of that, the kernel level optimizations, graph optimizations, I mentioned previously, quantizations, things that we can do to help customers run things cheaper. You may sacrifice on efficiency, or you may sacrifice on how accurate the model is, but sometimes that's okay. I mean, Jonathan, you just gave an example of ChatGPT told you a wacky answer. In a lot of scenarios, that might be okay if it just saved you a significant amount of money. The other thing, I skipped over my Edge slide, but one of the things we also do at Red Hat is focus on Edge deployment. So you all familiar with, I think you all are familiar with Edge, but I don't want to take that for granted. Is that a pretty common? Okay, so with Edge, we look at this as kind of multiple stages: the near edge and the far edge. Near, and I'll paint the picture of, imagine you're an industrial manufacturer, you make widgets, and you have a core data center that your business is run on, and then you have factories all over the world. Each one of those factories has its own data center with OpenShift running on it, and then each of those factories have cameras, right? And all the cameras are doing is they're doing some image recognition to be able to tell if the widgets you're producing are defective. And so you have those multiple layers of that. When you start to add those layers, it becomes very challenging for AI because there are certain complexities. When you get all the way to the cameras, those are low-tech devices, right? They may be running on some very restrained hardware. It could be a Raspberry Pi. It could be something that has very low memory, very low storage. If you try to throw a 1.5 gigabyte LLM on top of a camera, there's no way you could do that. And so one of the complexities is how do you look at the constraints of the devices themselves and do optimizations to where you can get similar comparable performance. And for example, with the imaging, Intel has this OpenVINO framework that gives you pretty good image detection capabilities just using CPUs. You don't even have to use GPUs. And then when you start to get a little bit more complex, the far edge, those are still low powered, low energy devices. They don't have a lot of hardware. They're a little bit more hardware than like the cameras themselves. But these are devices that could potentially have intermittent or totally disconnected internet. If you can think of the scenario, we were talking to one customer where they have container ships, and the container ship only gets back online maybe once a few days. So how do you allow it to do AI? Maybe there's a model that has to be pushed to it. You know, how does it collect all of the data? How do you then feed that data back to the central system without saturating the network? You need advancements in networking to be able to do that. You need smart filtering on the data that you're collecting. All of these complexities to be able to get that data back to the core, especially if it's either intermittent or total blackout of network. And even with drones, scenarios where drones may or may not have access to the internet to be able to send data back. One of the things I really wanted to touch up on, there's two more subjects here, and then I'll open it up. The corporate challenges. This is an important one because no matter how good your AI-infused application is, it can always be shut down by InfoSec or ProdSec. And you know, if you look at it from an information security perspective, InfoSec, their whole goal is to protect the data of the company. If you created some AI-infused application and you're sending your data up to ChatGPT, guess what? When you try to deploy that into production, they're going to shut that down and tell you have to redesign the application. They also need audit trails. As an AI model is making a decision, they need to be able to know what decision was made. Imagine you were just declined for a mortgage, and you know, you have no clue why, and the company that declined you has no clue why. That's not going to be a good scenario for, I'm sure Chuck Schumer would love to hear that story. And then when you look at ProdSec, ProdSec wants to ensure that the software has no vulnerabilities. People cannot penetrate the network. They can't do malicious activities. If you don't know what's in that model, the model itself could be malicious, and you just don't know it. And so we're working with companies like Hugging Face to look at ways in which you can not just have the open source model, but also the open source data that goes behind it, and provide capabilities for that lineage. We're getting asked all the time. In fact, we were just recently asked by a customer this week, can you help us with an open source strategy for providing lineage for these off-the-shelf models? This is a really critical area, and I think, you know, going back to Chuck Schumer, I was joking around about that, but that is a really hot topic. They want to know where these models are coming from, what's in them, and businesses also need to know that so that they can connect the dotted lines and have that transparency. And so you also want to be able to detect fairness in the models, because let's face it, most of us are not going to create our own models. We're going to take something from Hugging Face, we're going to take something from Meta, and we're going to start there and play around with it. So does it have being able to do bias detection, being able to explain the decisions? All these things are really critical for companies to understand. And I will tell you right now, it is the wild, wild west. No one understands this yet. There hasn't been any clear winners, and people are still kind of frantically trying to figure out how do they get answers to these tough questions. The last subject I want to talk about is the scale of infrastructure and what happens when you're actually trying to run some of these larger jobs. This is just a graph. This is full disclosure. This is not my chart. This is IBM's. Mine looks a lot better. But from an IBM perspective, they have infrastructure that in May of 2002, they had 800 GPUs. By end of year last year, they scaled that up to over 1,000 GPU nodes. Each one of those GPU nodes has 8 GPUs in it. So you're talking about a cluster with 8,000 GPUs. And on that, they're generating their own foundation models, time series models. They're doing some things with NASA, I mentioned before, NLP, all of these types of things. Now, what happens when you try to run that type of infrastructure at scale? One, they were getting a GPU node failing once every 4 days. Not a GPU. I said a GPU node has 8 GPUs on it. And when you have these jobs that are running for days, weeks, having this continued failure of GPUs can be catastrophic for you getting something out the door. And it's something that we kind of take for granted. I don't know how many of you are gamers? Do you guys have GPUs at home and play games? Those are the high quality GPUs. When NVIDIA sells you those, they sell you the best parts. Why? Because consumers, man, we complain a lot. But businesses, they don't have a choice. And so what happens is they sell them the cheaper hardware. They sell them the more commoditized hardware. And what happens? It fails once every 4 days. So as a result of that, what they're trying to do is figure out how can they have this autopilot type of thing that can help them recover from all of these failures. And so they've got some cool technology coming out of IBM research, but I wanted to talk through this, and John's getting engaged there as well. Like, how do you start to understand first when is a failure going to happen, right? Are there things, maybe it's a network issue, maybe it's something where you're running out of storage, maybe it's something where the hardware itself is failing, maybe the disk is failing. How can you do things that can help predict the failure of something, and then take it a step further, and how can you auto recover from that failure? Yes?
How is this different than, let's say, like a VM failure or CPU failures in the cloud? You just migrate and you kind of resolve it. Is there something specific about just GPU nodes that makes it harder to migrate stuff?
Yeah, so full transparency, I don't know everything under the covers, but I know this is specific to how you're monitoring GPU. So what you mentioned before, let's say, for example, Dynatrace, right? They have some of these capabilities where you can detect failures. They focus on generic metrics that are collected. What they're doing is focusing specific on metrics and patterns that indicate GPU failures. So the whole goal is very similar, but the way the approach of it is very curated towards a GPU failure problem, because it's just multiple layers. It could be a kernel issue. It could be an NVIDIA driver issue. That's the problem. It could be the hardware itself. I mentioned all those layers that you had in that stack. It's much more complicated than just an application being failing.
And the other thing I'd add to that is, in the application development space, one thing that my group used to be responsible for is process automation. And at the application space, it's very well understood. Well, it's better understood how to deal with, like, if you have a process that's running, a workflow that's running, and there's a failure, partial failure, how to distribute that across and restart. I don't think we have that level of understanding. We move data across, retraining across GPUs, and you have this failure. It's much more low level, and you don't really have this ability to quickly migrate and shut off and move jobs across. So I think there's just a lack of maturity in the software and the tooling and the understanding of how to do it. So it makes it different. So in reality, it may not be different at the bottom level, but in terms of our understanding, our ability to react to it today, it is very different.
Yeah. Yeah, and I think John raised probably the best point there is, a lot of these jobs are running on hundreds of GPUs. And if only one fails, that doesn't mean you should start your entire job from scratch. And so it's a little bit of a different challenge when you're talking about these distributed workloads. So that's one that I'm really closely following. We know that there are instances where this happens on the training side, but it's also going to be a problem on the inferencing side. If you're making a call out to an LLM and that GPU just happens to fail, and you were in the middle of a conversation with that LLM, what happens? These are questions that we haven't answered yet. Like, the industry's not ready to answer those types of questions. But it's something that I'm excited to take a look at. So that's it. I've spoken a lot. I've mentioned a lot of things. I think this space is cool. I hope you all too. I hope you didn't just come for the food. But if I'm happy to take any questions or go back and go deeper into any of the topics, or if I hurt your brain and you guys want to sleep for the next 10 minutes, you can do that too. Yeah.
So one quick thing, right? Just bringing it to the relationship that we currently have, my group and another faculty with Red Hat. You mentioned that one line of work that is part of this effort is to optimize key applications even down to the level of kernel. What about down to the level of hardware?
For Red Hat, we are not necessarily in that space, but we work with our partners for that. So, for example, we have strong partnerships with Dell, with Intel, with NEC, Supermicro, Cisco. In fact, we just announced last week a validated AI pattern with Dell, which is their optimized infrastructure, their optimized hardware running on our optimized software. We did the exact same thing with Cisco. We announced it was like Dell beat Cisco by like 1 day with the announcement. So we do work with our vendors where they focus more on the hardware optimization. And what I was trying to say is we need to make sure the kernel side is optimized to run on that hardware as well.
I guess my other question, tangent on that is one keyword I never heard during this presentation. You talk about a lot of CPU, a lot of GPUs, right? What about FPGAs, which you can have and potentially you don't just optimize the model, but also optimize some key engines that allows to do the same operation with a fraction of the watts?
Yeah, that's a simple answer. I will talk about it as soon as customers ask me.
Okay, customers are not knowledgeable enough to know that they need it.
But they also aren't buying them. They're just not like not the customers we talk to. So we've been in the FPGA space, lingering around in it. We've done some work in it for quite a while. I have, of the 6 years I've been doing this, I've not run into one customer it's almost like saying, hey, what about that Power 9 customer? That one guy, maybe.
But maybe this comes back to the
no, but that's the difference between like enterprise versus research. It's very interesting research wise, but when our customers aren't asking for it, it just doesn't come up.
But maybe this comes back to your prior comment, right? So unless we in research can translate it into the dollar cost savings,
Yes.
We've seen
Yes.
this opportunity.
Yes.
We knew that both training and inference and all of it is much like high performance computing was. And when the government said, by God, you're gonna build me a supercomputer that costs a fraction and has a mean
Yes.
time to failure, despite having well over way more nodes than the GPUs have. We have a mean time to failure there that's in the months because we decided that the cost was worth it, but it was subsidized by the American government at the time.
Yeah.
But in the same sense, if we know that we have a pathway to expressing our result in a dollar that makes sense for you to be able to say,
Yes.
oh yeah, you know something? That's
Absolutely. If we were to say, hey, if you guys switch to FPGAs, you get comparable performance and it reduces your overhead by X, I will put that in front of every customer.
All right.
No problem at all. No problem at
You
all.
got yourself a deal.
Oh man, was this recorded? Sorry, I think you're right.
What's your attitude or outlook on open source licensing in this world of?
I am not a happy camper. There are some posers out there, and
Like all of them?
gosh, I want to name drop.
We will.
It's
One
not-
has
we
a
can
face
post
on it.
Yeah. Two of them have a face on it. Meta face, but so great question. We are working closely with IBM. IBM is launching what's called the AI Alliance, and Meta is part of that. We are part of it. We have some others Meta is actually going to be they're co-launching it with us. And so the goal here is to provide more transparency up and down AI/ML from the infrastructure all the way through to the models and the data that it's trained on. I would like to push those questions and really say, you know what, your license is cute, but it's not really open source, and really push that into because the reality is there are only a few companies that can do generative AI at scale and make revenue off of it. Everyone else is going to play catch up. Open source has to be the way that we play catch up, right? Because everyone can contribute and pull resources together. But it can't be, this is great for academics, but the moment someone wants to monetize or commoditize it or commercialize that, then you can't compete with the originator of that. That's not the true essence of open source. And so I think a lot of these licenses, they seem to be open source until you try to do a commercial model, and then that's where it's restrictive. So to me, in order for us to really democratize accelerating AI and not just make it the 3 or 4 companies in the world that can do it at scale, we're going to have to address that, and we're trying to do that with that AI Alliance. Yes.
So you talked about optimization down at the kernel level, and oftentimes that you're speaking my language now, but oftentimes we're hampered by access to code bases. I can't look at the NVIDIA driver, and I'm sure it's a pile of dog poop because it performs like it. But like oftentimes that anybody who makes GPUs is not sharing drivers. So
Yeah,
how are we
that's
going to combat that? It's very hard to optimize code we can't touch.
Yeah, that's a very fair point. In fact, we struggled with that a lot. We were trying to optimize for TensorFlow at the time, and we had challenges there because it was closed source. AMD is playing in this space really nicely. We're establishing a stronger partnership with them. Intel with their GPUs, they're becoming more competitive, so we're doing more with them. And we also, I don't know if you saw it on the slide, but Intel with the Habana Gaudi, that has great promise, and that's open source as well. So there are, really NVIDIA is kind of the only one we deal with that has closed source, and it does make it challenging. It's not impossible. It's just a different type of relationship where we actually have to work with them and they have to do the work with our guidance. It's a challenge. It's not as easy as working with some of the ones that are open source, but it's not impossible. So that's kind of what we've been doing lately. I think we've had some great relationships with the open source drivers, but it's an area that we have to ramp up in, and even if we just started on the PyTorch level, I think that would be a tremendous gain. And then if we can go all the way through to the GPU level with the drivers, then that would be fantastic. Any other questions?
There is one on Zoom.
Oh, yes. I'll read it. Is there a chance Rhodes can add a feature that allows us to configure custom open ports in a Rhodes workbench to expose a running microservice we have developed in the workbench? Oh man, that had to be Chris asking that question. You can open a Jira ticket, Chris. No. I will have to get back to you on that to see what's on the roadmap. So let me see if I can I see that one more time?
Yeah.
Let me make sure I understood this.
I'm gonna add a feature that custom open ports expose a running microservice.
Yeah, I'll have to follow up with you on that, Chris, if you're still on the line. I don't know if we have that on the radar, but I'd be curious to understand your use case there, and why, what you're trying to do there. But I'll also say, Chris, OpenShift Data Science is now OpenShift AI, so we have to call it that.
So I actually happen to know what the use case is. So.
Oh, cool. Yeah, there we go, Heidi.
So there are programs for automatically generating websites that people at BU like to use. And so Chris was trying to look at whether we could use those programs, and they needed extra ports in order to bring them up.
Oh.
And so it's like the researchers are used to these tools and they've already got their workflows all laid out. And sure, we could write software that would do that, but it's not the thing they're used to. So that's why he's asking.
I would love to take that back as some requirements back to the team. So yeah, I can follow
Yay,
up
researchers.
with you guys. Yeah. I'll follow up with you, Heidi, and
Yeah,
and
we'll
Chris.
send you a description. For
Yeah. By all means, anyone can open up a Jira ticket and request anything. Doesn't mean I'll do it, but you know.
For the record, if you do open those, provide the capability of opening ports, I'll happily find other uses for it.
Awesome.
So I'm just
That
gonna.
sounds like an infosec
No, I'm a
problem
good guy,
waiting
I'm a
to
good guy.
happen.
Me and my 300 other students, we won't hurt anything. I promise.
Jonathan, I was talking to Chris separately here, and I'm going to look at it because part of that is just a general OpenShift question. There's a question, there's some part of Rhodes that may be involved that I'm not familiar enough with that to address that one. But in general, in OpenShift, you can't just expose an arbitrary pod kind of by design, arbitrary port by design.
Yeah.
And so that's an outside of Rhodes question. And that's probably a solvable one that we can look at right now But if there are parts of roads that make that extra difficult in the roads environment, then that's
Yeah.
gonna be Sherard's issue.
Or maybe we should do a better job of abstracting it and making it easier.
Gateway API.
Yeah, something like that. We're also integrating our service mesh into what we're doing a little bit more that'll make it easier to serve. So Kserve integrates with service mesh, which is also Istio, open source project Istio. It should make it easier to have those endpoints for your models being served up. So I'd be interested to see if we can kind of solve some of those problems with some of the work that's going on. Awesome. Any other questions? Awesome. You guys have been phenomenal. Any complaints, send it to John. But I'm happy to stick around for a bit, and if I would love to at some point also see if we can maybe connect the dots with some research work that you all have done that could possibly be useful. I'm always looking again for free labor. But thanks everyone.